Hi everyone, I hope you are all fine. Um, Today we will solve some questions from the chapter 1, Logic, specifically section 1.1 sets, and some questions about from the section 1.2 propositional calculus. Okay, so this is week 1, recitation 1. This means you will receive another video, which will be week 1 recitation 2. So basically in each week you will receive 2 recitation video, and please watch them on Wednesday. And if you have some questions to ask, or not from recitation, maybe from our textbook, you can join our online live meetings on Thursday, uh, so that you can ask your questions to Gülşah or me, to me. Okay. So week 1 recitation 1, as I told you, this is basically we are in chapter 1. The name of the chapter is logic. Okay. And section is 1.1, which is sets. So in this video we will solve questions from this section. Okay. So let's start then with the question 1. Let's start with the easy one. So problem 1, let's say. Problem 1 is the following. Let this is very big, sorry. Okay, better. Let A be a set which consists of 1 and 2 as elements. Okay. Uh, the question is the following. Find, first question, I to I, the power set of A. Second question, the power set of A. Okay, so before solving the question, let me give you some basic information in order to understand the idea of the question. First, let me start with a remark before solving the question. So we have a remark. Let me use blue color this time. Okay, so our remark is the following. If you have a set A which has cardinality n, this notation is for cardinality, the number of elements, the number of elements of a set. Okay, so if you have a set which has n many elements, then the cardinality of power set of A, sorry, 2 power n. So if you have a set which has 5 elements, which means the power set of A has 2 power 5, in other words 32 elements. Okay, so from this fact is important. We will use this fact. Actually it is proven in the lecture videos you can watch. Okay, so we will use this information. It will be helpful to determine how many elements we will have in each uh, part of the question, part I and part 2I. Okay, so before starting, and this is also very important, let me write it down. Note. Actually, this is nothing but the definition. The power set of A means the subsets, the all subsets of the set A. So basically, if A is in A, this implies this is a subset of A, and this implies this is an element power set of A. So this is what you need to be careful about. Okay, so this is basically what will we do in this question. So let's start with the first part of the question, solution I. So I am asking what is power set of A. Okay, so note that empty set is a subset of A. Actually, empty set is a subset of all set. Okay, empty set is a subset of all uh, of any set. Okay, this implies uh, empty set is in the power set of A. Okay, and note that 1 is in A, which implies the set 1 is a subset of A, and this implies this is the element of power of A. Okay, power set of A. Similarly, 2 is in A. This implies this is a set which is a subset of A, obviously. This implies 2 is an element of a power set of A. And finally, I am saying finally, why? Because the cardinality of A is equal to 2, right? The set A has two elements which are 1 and 2. So this implies the cardinal, thanks to our remark, the number of elements of power set of A is equal to the 2 to the 2, 2 power 2, which is 4. So the power set of A must contain exactly 4 elements, and which are these, these, and finally 1 and 2, both of them in A, which means 1, 2 as a set is a subset of A, which implies 1 comma 2 is in the power set of A. So this is the last element, the power set of, so power set of A contains 4 elements which are empty set, the set which contains only 1, this, and finally this. Okay, as we said before, the cardinality of power set of A is equal to 4. Actually, you can see it is true. So what about the second part? It is a little bit tricky, but still not hard. You can solve quickly. Uh, You need to write down every element, each element carefully so that you don't forget any element of power set of A. First of all, we can use, still we can use, so what I am asking, sorry, power set of A. I am asking this. So what is it? Um, so first of all, note that the number of power set of A is equal to 4. This implies, thanks to our remark or proposition, the number of the cardinality of the power set of A is equal to 2 power 4. 2 to the power 4, which is 16. So this set may contain 16, exactly 16 elements. Let me write it down. I will write a few of them and the other will be exercise. So let me write at least 10 of them. So let me write, let me use big set notation because we will have, 16 elements, right? First of all, clearly empty set is a subset of power set of A, right? So this implies empty set is in power set of A. So let me write the first element and observe that 1 is in power set of A. You can check here. This implies the set which contains set 1 in subset of power set of A, and which implies and this implies in power set of A. So this is, and the third one is similarly by using similar idea. This is also in the power set of A, and clearly this is also this element is also in the power set uh, of A. And note that empty set, you have to be careful here. Empty set is an element of power set of A, right? You can see here. Okay. So this implies when you take the set notation, when you put into the a set, which will be a subset of uh, power set of A, and which will imply is an element power set of, since because of this fact uh, the set which has an element empty set is in the power set of A. Okay, so this is also, but not that this is empty set. Be careful there. This is not an empty set because it has an element which is empty set. This set is not an empty set because it has one element which is empty set. The element is empty set. The set is not empty set. Okay. So be careful here. This is the difference, big difference between empty set and the set with an element empty set. Be careful. Okay, then what about the others? You can check this 1 and 2 in let me write it down in an order. So empty set and this set is in the power set of A. You can check above, right? Empty set and the set which contains only one element, which is 1, is in the power set of A, which implies the empty set and this set is subset of power set of A, which implies is in the power set of A. So let me write it. Okay. And similarly, by using similar argument, you can conclude that this is also in the power set of A, and also this one. Okay. And also this one. Let me put big commas here. And this one. So 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5, 6. Okay. And you can continue like that. So you will write down, you can see this also. These are all elements of power set of A, which implies the set which contains these three elements is clearly subset of power set of A, and this implies, thanks to the definition, empty set 1, 2 is in the power set of A. So let me write it also. So empty set 1, 2, and similarly you can write other, and let me write the last element, but there are some other elements in here. As I told you, there are 16 elements. The other ones, let me write it here. Let me write it quickly actually. So it is enough for you just think the solution of the question. Okay, I will write down everyone, each element of the power set of A. Only understand how I found them. Okay, so far I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is the other one. Sorry. Okay. And the other one. Okay. And let me write it here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And let me write the last one, which is nothing but the whole power set of A, which is empty set 1, 2, and 1, 2, and close it. So this is the set I am looking for. It has 16 elements. Okay. So question 1 is done. Okay, let's move on to next question, which is problem 2. So problem 2. Problem 2 is also an easy question. Let me write it down. So the question 2 is the following. Illustrate the following laws by just drawing Venn diagrams we assume that all the sets are subsets of a universal set, capital U. Okay, So let me write the parts. So part A, which is A intersection B complement is equal to A complement. Of course, the A complement is also must entirely inside the set universal set U, right? So A intersection B complement must be equal to the A complement union B complement. Let me serve. Let me solve first part A. So let me sketch it in order to understand. Actually, this is not a proof. This is just an illustration. Okay, this is not a proof. So if you want to prove this equality holds, you need to use set theoretical arguments. Okay, this is just an illustration. Be careful. Okay, then let's start with the part A. So let me sketch the universal set U. And I have a set A and set B. So it says that it in the first part, I am looking this. It says the complement of A intersection B. It will be, so this is A intersection B. So complement of A intersection B will be everything except intersection. Okay. So what about the right hand side? Let me sketch one more time. So this is the universal set U, the set A, the set B. It says the complement of A, which is this, the complement of B, so their union, which is again the same set, the whole also here, of course. So the red areas represents the uh, either A intersection B complement or A complement union B complement. They are the same. Okay. So part B is the following. A intersection B union C, which is equal to A intersection B union A intersection C. This is nothing but actually distributive law. We know this is true. Let me illustrate by using Venn diagrams. Let me sketch left hand side. So I have A, B, and C. Again, A, B, C. Okay. So B union C intersection A. So this is B union C, and it says intersect with A. So let me sketch A. So since it says intersection, this is the region I am looking for. Okay. Now let me do it right hand side. A intersection B. The A intersection B is here, and A intersection C is here. It says take the union, so all of them. So you get the same area, same region. So they must be equal. But once again, this is not a proof. This is just an illustration. Okay. This problem is solved by me because of the fact that You better understand the concept of Venn diagram. Okay, this is not a proof as I told you before. So C, A union A complement, which is equal to the universal U, which is also very easy. Let me sketch the universal set U, and let's say this is A. So A union, A is here, and A complement is here. I am taking union, which means everything is the must be shaded. Okay, so which is equal to U, obviously. Okay, and also you can observe that uh, A intersection A complement is an empty set, which means A and the set A and the set of complement of A are disjoint sets. So part D, let's move on to next question. Right part. Okay. C, set difference. This is the notation for set difference. A intersection B, which is equal to C, set difference A, union C, set difference B. Okay, let me sketch left hand side. So this is A, B, C. Let me sketch one more time. So this is A, B, C. So what is A intersection B? Here. And I am asking C set difference C minus A intersection B. It will be okay, this area, this region. Okay. What about right hand side? Uh, C set difference A, which is here. And C set difference B. So I am taking union. Okay, so the region I am looking for the same region. Okay, okay, that's enough for this question. So I have used Venn diagrams to illustrate some equalities. Okay, indeed, some of them are well-known equalities, like distributive law. Okay, let's move on to next question for for the first part of the recitation week 1. So I am so problem 3, I guess. Yeah, this will be last question for the week 1 recitation 1. Okay, so let me write the question. Give examples of sets to show that the following statements are false. Are false. Okay, so let me write all the parts. A, B, C, and finally D. The first question is A union B is equal to A intersection B. This is of course wrong, right? You can give lots of examples. Let me give a few of them. Let's say one example is enough. False, of course, as the question says. One specific example is enough to say that this equality doesn't hold or this statement is false. So you can take A 1, 2, 3 and B uh, 1, 2. So clearly A union B equal to 1, 2, 3 and A intersection B is equal to 1 to 2. They are clearly not equal to each other. Let me write below. So A union B is not equal to A intersection B. So this is false. False statement. What about the part B? A set difference B is equal to B set difference A. So this is also false. Let's think about a specific example to show that this equality doesn't hold. I guess this example is okay. So again, okay, and B, you can use other examples. For example, you can take A as any set and B empty set. So empty set difference A will be empty set. The right hand side will be empty set, but the left hand side will be the set A. So clearly they are not equal. This is alternatively one can choose the one set as a empty set as an empty set. So clearly it is also enough to show that this equality doesn't hold. So you can immediately say that this statement, the part B, is false. But this is also do the job, because what is the A set difference B, which is clearly 3, right? I am looking all the elements in A which are not in the element of B. I have only one kind of element, which is 3. One element. Okay, satisfy the definition of A set difference B, which is 3. What about B set? B set difference A, which is empty set, right? Because the whole elements in the set B are also in the set of A, which means there is no an element which is in B but not in A. In other words, B set difference A must be empty set. Clearly, empty set. Clearly these are different sets. One has cardinality 1 and the other one has cardinality 0. So these are not equal set. You can construct lots of example, but as I told you, one of them is enough. Okay, one of them is enough. You don't have to find uh, two different examples. One specific example does the job. Okay. So what about the part C? Uh, Part C, it looks like a distributive law, but it's not. That's why it is wrong. Okay. So A union B intersection C is equal to A intersection B union C. Of course, this is also not true. You can choose C as an empty set, then everything will be uh, clear, I guess. Let A 1, 2 and B any set, maybe just 3 is also okay. I guess no. 2, 3 does the job. Okay, so 2, 3 is better. And C empty set. What about A union B, which is 1, 2, 3, 1, 2, 3? Okay, And what is A union B intersection C? Since C is empty set, this is an empty set. Okay, so left hand side is empty set. What about right hand side? A intersection B is equal to 2 because the both sets A and B has the element 2, so that's why A intersection B contains 2. So what about A intersection B union C? It is again 2, right? Empty set union something is something, so this is A intersection B because C is empty set, which is 2. So clearly 2 is not equal, empty set is not equal to the set which contains 2, which means A union B intersection C not equal to A intersection B union C. This is not true always. So this statement false. It must be true for each ABC. But you can find a counter example, a specific example which fails the statement. So you can immediately say that this statement is false. So what about the last part? The last part seems a little bit tricky. So A complement intersection B complement must be equal to A union B. Okay then. What about let me introduce a universal set. Let's say this is 1 2 3 1 2 3, and A has 1 2 and B is 2 3. Okay, I guess this example is okay. So what about A complement? A complement is just 3 because A complement means you set difference A, which is just 3. What about B complement, which is 1 only because it is U set difference B, okay, which is B. So what about A complement intersection B complement, which is empty set clearly. What about A union B? A union B is 1 2 3, which is equal to universal set, and clearly the empty set is not equal to universal set, which means A complement intersection B complement is not equal to A union B. Okay, so the statement in the party is also not true at all. Okay, so this brings me to end of week 1 recitation 1. I hope you are enjoyed. Do not forget to subscribe my channel and doesn't forget to like videos. I'm just kidding. If you have any compliments, you can write down under the uh, YouTube video, or you can just email to me. And as I told you, you can ask your questions tomorrow on Thursday to Gülşah or to me. The online live recitation times are written on Ottuclass. You can come and ask your questions. Okay, then, so that's enough. And do not forget to check your emails regularly. And please, especially, please visit Ottuclass, our Ottuclass regularly, okay, because on Otto class you can see the textbook, you can see the some important announcement, you can see some videos which is separated week by week for each week, um, and you know everything you will need will be also in Otto class. uh, in addition to our course website. Uh, we will put everything on our website, but we will put everything also on OptiClass. So OptiClass will be enough for you to just follow up announcements and the textbook we are using, how many videos are uploaded, um, you know, the other things, everything about our course can be found and seen on OptiClass. That's why I highly recommended that you do to visit our OptiClass webpage, our OptiClass page regularly, weekly, indeed daily. Okay, so have a nice day. See you. Bye bye.